Many of us have seen them, been fascinated by them, excited by them. Maybe have found them a little daunting. AI robots are here and they are being built with purpose. Robots are being used in all sorts of industries, including manufacturing factories, healthcare and operating theatres, and even in the military. The future of AI is being defined by companies like Boston Dynamics, who are at the forefront of cutting-edge technology, looking to expand our world and seek opportunities to use automation. In this episode, I speak to Andre, a product manager at Boston Dynamics, who is working on Stretch, an AI robot that's revolutionising the warehouse environment, a space that typically demands hard labour performed by humans. In this episode, we explore so much of the amazing work going on in the robotics and automation space. And of course, I ask those questions that's on everyone's mind when it comes to the future of AI in today's world. Can't wait, neither can I. Let's get into it. Hello everyone and welcome to another episode of A Girl in the Product World. I'm your host Amna, and today I am joined by a very special guest, Andre. Andre is a senior product manager at Boston Dynamics, a company based in the US which is developing robotics to tackle some of the most toughest challenges in industry. Previous to BD, Andre had built up a huge experience in his current field, working for Universal Robots and Rethink Robotics. Andre also holds a mechanical engineering degree from the Roger Williams University in Rhode Island. He joins me today to talk about his inspirational work, which is enriching the lives of many. As an AI alumni myself, who many years ago sat in a lecture room watching a video of some of the first robots to be built by Boston Dynamics, I cannot tell you how excited I am to have this conversation today. So let's meet him. Andre, hello.
Hi, Amna. How are you doing today? Thanks for having me.
Very well, thank you. The pleasure is all mine. How are you doing today?
I'm doing very well. Very excited to be here. It's an honor to be with you.
It's an honor to have you on the podcast. And like I said, I cannot wait. So shall we get into it?
Let's do it.
Brilliant. Andre, please, in your own words, could you tell us about your journey and what's led you to where you are today in product?
I would love to. So my journey really into robotics started after I graduated from my university. I did do a brief research project in my undergrad days, but really started picking up robotics at Rethink Robotics. I joined the company as a field applications engineer, and was in the trenches. I was visiting customers all over the world, doing all of the things that applications engineers do, especially for a startup, right? So wearing many hats, and so from there, I moved to Universal Robots after being at Rethink for a few years, and also did something similar at Universal Robots. And then I was fortunate enough to have an opportunity to jump over into product management at UR. And so when I was at UR in product management, I got the chance to work on a number of different products. I started working on web-based products, and then I moved over to products working on the core robot software. Earlier this year, my journey took me to Boston Dynamics, where I've been for the last 6 months, and it's really flown by. It feels like I started yesterday. And so at BD today, I work on BD's newest robot called Stretch.
Amazing. And I cannot wait to get into more about Boston Dynamics and all the work that you're doing with Stretch. In our previous conversation, I was just blown away by how much is actually being done and the area that it's being used in. So thank you for sharing that with us. Now, getting straight into the robotic side of things. Now, you currently work for Boston Dynamics. Could you tell the audience who Boston Dynamics are and what impact they're trying to have in the world today?
Sure. So maybe a good place to start would be by sharing Boston Dynamics' mission, which is to imagine and create robots to enrich people's lives. So Boston Dynamics, I think many people have heard of the company. We do have a pretty strong presence on YouTube with some of our robots. Most people are familiar with Atlas, which is our humanoid robot, and Spot, which is our quadruped robot that most people call the robot dog when they see pictures and videos of it. Um, and so today, the project that I'm working on is the stretch project. Boston Dynamics has had this history of robots that are mobile, right? We see that trend with our Atlas and with our Spot robot. And a few years back, we had Atlas doing a demo of picking up a box, and we got a lot of interest from these different warehouse customers, and they reached out to us and said, can we have Atlas to do that in our facility? And so that inspired us to work on a different type of a mobile robot. This time, a robot that doesn't have legs, but has wheels and is designed for the flat floor of the warehouse. That's how the stretch robot came to be after the evolution of a few different concepts and prototypes. The model we have today is, again, a mobile robot that has the ability to understand and sense and perceive its environment, similar to Atlas and to Spot. But in this case, we're working in the warehouse environment.
Amazing. So just to give a bit of context in terms of the warehouse environment, why was there such an interest to use a robot? I'm assuming that it would be to kind of not take over, but to assist in human activity. And I'm thinking of warehouse. I immediately think of something like, I don't know, like an Amazon depot where there's a lot of heavy boxes. What inspired them to want such equipment in their warehouses?
Yeah, it's a really good question. Robots are not new to the warehouse. However, the types of applications that Stretch is working on have previously, there really hasn't been a great solution for that. And it's a very painful task to stand in a hot container or even a cold container, right? Basically, the containers are exposed to the elements. And essentially there's a team in there that is lifting the boxes out of the container and then putting them onto a conveyor belt, and then they'll go into the warehouse. And it's a very labor intensive task. It's something that people really don't enjoy doing, as you can imagine. Some of the ports that we're working in today are in the southeast of the United States, and the southeast in August is very hot. I was just there earlier this week, and it gets to be quite toasty inside the containers, even inside the warehouse, and it's just not very desirable work. And so when you look at the perspective of the warehouses and the operations teams, you have a lot of turnover. Right. So that's a big thing. Employees turning over, not really being very interested in doing the work for a long, extended periods of their careers. There's a lot of instability that introduces into your warehouse operations. So that's a lot of those ingredients, those sort of fundamentals, are what leads companies to look towards automation. And previously, there hadn't really been, like I was saying earlier, hadn't really been a great solution for handling cases in a way that was fast enough. And really, that's the main metric is speed, but really in a way that can also be done safely and at a cost that's something that is affordable and something that can be justified as well for these warehouses. So you kind of take all of those pieces together and you package them up. And then, now we have the stretch robot in the field that allows these warehouses to really optimize and stabilize their operations. And it allows the workforce to do tasks that are not exposed to those harsh environments, right? So the workforce itself doesn't change. So the numbers of the headcount and the staff, the numbers really stay the same. It's the labor gets repurposed to other areas in the warehouse. As you'll notice, like warehouses and factories, they're always hiring, right? And so that's really the beauty of it. They are, in fact, always hiring. And so it's really an equation of repurposing the labor and having the robot come in and do something that nobody really wants to do, first off. and second off, it's just a really, really difficult job, right? And so we allow the operations teams in the warehouses to kind of think about that, and then look at where the labor is more appropriately used, and then that allows them to sort of overall have a little bit more stability in their operations.
So that sounds like a very nice happy ending, because I know the perception sometimes is, oh, these robots are coming and they're going to take over people's job. But what you've just mentioned there is quite the opposite. They're actually doing jobs that people don't actually want to do. And I'm so happy that also that you're seeing that repurposing of manual labor somewhere else, which I think is a very important point to put out there. Is it's not a case of we're doomed, these robots are coming and taking over, rather that humans are able to do work that where they can apply more skills and actually be better serving better somewhere else.
Yeah, that's exactly right. And that had been the same trend as well, coming from Universal Robots. And really, if we zoom out of the robotics world and just kind of look more broadly at technology, and even some of the generative AI tools, right? These large language models, and there's just loads of examples of even going back to the days of the computer, right? You had people doing a lot of manual work on pen and paper, even on typewriters. And so there's just it's this continuous theme of automation that there is obviously going to be a near-term impact in some way on the workforce, but it's really about sort of the longer term. And I think there's a really important aspect to all this to consider, and that is that the workforce, especially in the United States and in other countries around the world, is aging. Mm-hmm. So you have this dynamic where you don't really have a lot of young labor sort of backfilling a lot of these older positions that are very quickly approaching retirement. Mm-hmm. A story I love to share is a warehouse that I visited earlier this year. A week before I had been there, they had brought in a bus. So the bus was to bring 30 people out to lunch for their 30-year service anniversary at the site, right? So there you go. That kind of tells you a little bit. I think that story, there's a little side plot there, of course, that talks about that site in particular and being able to take care of its employees. And, many employees do stick around there for many years, which is a great, culture and a great environment to have. But the point that I was also getting at was, you have this sort of these large groups of people that make up the workforce at these different sites, both in manufacturing and in warehouse operations, that are in fact aging. And I think there's really something that's been discovered, that younger folks that are coming out of universities and coming out of high school are not particularly interested in doing a lot of these jobs.
Yeah, and wow, the 30 anniversaries, I think that's pretty much unheard of amongst, I would say, our generation. It's incredible. But something also that you said there, which really struck out to me, is basically an evolution, right? And I think, like you say, zooming out to just computers and what they're able to do for us, it really it reminded me of when NASA, they would actually have job titles called calculators. So people were calculators, and they were the people powering the number crunching, etc. So it just shows that this is part of, I guess, natural evolution of where we're going as a world, and not really something to be scared of. Now, my next question is a little bit tied into this, and it's an age-old question that I've got to ask, with AI and robotics, especially having hit the scene, how do you see robots and also AI impacting the workforce, kind of beyond what we've spoken about within the warehousing side of things?
Yeah, sure. So I like to really focus on more, I'll say, concrete examples of AI and robotics, and sort of how those two play. I think there's a lot of discussion around, what is the future and where could it go one day? And I think those discussions are certainly valuable to have, right? There's no question about it. But for me, I really like to spend my time almost taking inspiration from some of the really cool like innovations that I've seen sort of over my years of working in the field. Um, and it can definitely sort of give a bit of a hint of where things might go. But I think it's more for me. It's easier to sort of ground the story in some more concrete examples. One of them that comes up as one of my favorite ones is the tossing bot from Google. So this came out of the Google Robotics Lab, and what was so fascinating about this for me is because it has such a real, um, just a relatable kind of story behind what the project was all about. So you have a bin of random objects. We'll say just to keep it simple, we have balls and markers in essence, right? Things of like noticeably different shape, and the tossing bot was able to um, uh, through its machine learning and AI, was able to find ways to pick up those parts and then throw them into a 3x3 array, and basically sort out the balls into this square and the markers into this one, and then different parameters. And so that's a really cool example of like they did a side by side comparison with a human standing at the same distance away from the 3x3 array, and humans were far less accurate, right? So you can imagine this situation where, like, what is the commercial application potentially here? Like a bin comes into a sortation facility, maybe at an e-commerce, like an Amazon type of a warehouse. It's just filled up with all different kinds of, you know, toothpaste and whatever, just like anything that you could possibly buy on Amazon, just kind of sort of thrown into a bin. And a robot can sort of pick that up and now like sort it out in a much more accurate way than potentially than a human could, in a much faster way. And so what was really interesting about that for me is, we all understand what it's like picking up an object and trying to sort of toss it right a few feet or a few meters away. And it can be difficult, and especially when it's a marker, for example, that has these weird sort of dynamics where it can, rotate and flip in strange ways. And I don't know, I just found that one was really, really fascinating, that whole project, um, because for me it's just such like a relatable exercise of being or that or in your surroundings, and just maybe throwing over the car keys to your roommate or to your spouse or to your coworker. And so I was just really fascinated by that example.
That's really cool. And with the sorting one, I could also imagine that in homes where you need to tidy up. And I'm thinking of when we've had like kids over and there's all sorts of Lego pieces everywhere and markers. So that would be awesome. A household cleaning robot. Um, so that's really interesting. Now we have discussed a lot of the benefits um and address some of the misconceptions surrounding robots and automation. But what are some of the challenges that you come up against, whether it's with building the robots or actually inserting them in environments such as the warehouses? What are some of those challenges that aren't always as obvious as we may think?
Oh, absolutely. So, I mean, the first challenge that really comes to mind is around safety, right? So, when you have automation and robotics and there's humans also in the same environment, you have to think very carefully about safety. And the good thing is that there are industrial safety standards for robots that exist and that sort of govern and regulate this whole approach, and how things have to be integrated in a certain way. And that really keeps people at safe distances from robots. However, designing a system to operate like that is quite challenging, right? Because you have to understand what's the environment, where are the potential entry points for humans, how are we monitoring those entry points, and so that can be definitely definitely a challenge. If I take a step back, I think I forgot to mention this earlier. Stretch today, the application is truck unloading. So the robot is inside of the container. There's a conveyor belt that is either attached directly to the robot or essentially right behind the robot. And, the robot picks up a box and rotates over and then places the box onto the conveyor belt. And that application as a whole also has a whole host of challenges that are involved. If you think about some of those steps, the robot has to first off understand, where am I relative to the wall, right? We call it the facade of boxes, the walls of the containers, the ceiling of the container as well, even the entry of the container for maybe some of those same safety reasons. And then from there, we have to scan the boxes. We have to identify which box we're going to pick next. We have to decide how we're going to grab that box, right? Because the robot can take one of thousands of different paths to reach out and find a way to handle that case. So there's all sorts of different challenges there. And then ultimately what that all ties up or rolls up to is the speed at which the robot can unload, right? And that's the important metric that all of our customers care most about. And so when you sort of tie in this larger system with the safety, with the perception and the understanding of the environment, and then the ability to work in a way that is fast enough. And then you also have the user side, right? So that's the area of the product that I focus on quite heavily is the user experience. So I work with our phenomenal design team, and we look at all those different, nuanced ways where somebody might interact with the robot. Everything from the lights to what is the user interface, and how can we make this as simple as possible for people with poor vision and dyslexia, right? So there's a whole bunch of different angles there that sort of span the full spectrum end to end of the product operating, as well as users operating the robot, right? And what that means, and then how that sort of ties into the bigger picture of the warehouse operations.
Yeah, I mean, just as you're talking there, in my head, I'm thinking of all sorts of things that you'd have to consider, even things like, I'm sure, like the material of the boxes, and can it handle the force of a robot picking it up? And is it raining that day? And, is that kind of maybe confusing the sensors or something? If a worker is maybe considerably shorter, there's so many things that you have to think about. So that's really cool. And when you do pick up on these nuances, because I've got no idea about what development is like in the world of robotics, how long does it kind of take to develop a nuance or use case that you found and successfully deliver it for a better user experience? What does that look like?
Yeah, that's a great question, and that's really sort of the golden question in a lot of ways too. As a product manager, we press our engineers to try to help inform us as the product managers to help understand what is the effort involved here, right? How long might this take us? We do have the good fortune of having very smart and talented engineers, like many companies do, and since I've been on board at BD, I've noticed that our architecture has really been masterfully set up in a way where we can act quite quickly. So we see a challenge, a problem. We have longer term challenges that we're working on uncovering, and we know that are not going to be potentially in our next release, or maybe we'll put an incremental sort of midpoint into our next release while we still evaluate the longer term. Have we really solved the problem? And so it's an ongoing discussion. It's really everything from the kind of the day to day of working with the engineering teams to those moments when we step back and we look a little bit farther off into the future, and we say, hey, we have this particular challenge that we inherently know will be difficult. So let's begin breaking that problem down, right? We don't need to handle every corner case today, but we definitely want to, put together that plan for, okay, what is the next step to prove to ourselves that, we've uncovered kind of the next large sort of leap, right? And then from there, that sort of iterative process carries on. And I guess you fast forward, and some of the longer term projects you fast forward, and then you have your next great feature. And ideally, we're working in this cadence where we have our design teams involved, and they're thinking about some of the user experience aspects of what that feature entails. We have the product managers involved, and we're keeping our finger on if that feature is really driving at the current pains that we're picking up from our customers. And then we bring all that information together and we work with the engineers. And it's really the engineers that come up with all the solutions, right? I'm not the one that comes up with the solution. It's the engineers. But my job is to help the engineers then channel those range of, it could often be 10 different solutions for any given problem, and try to really channel that so that we can come up with that right balance of effort and architecture, and really making sure that ultimately we're tackling that pain that we uncover by visiting our customers and really sort of listening to them, being right there and understanding firsthand like what is making your day worse today, right?
Mm-hmm.
That's like a very high level question that we can ask. Like what is still like bothering you about the system? What really kind of targeting those core pains. And so I guess that's a long-winded answer, but that's kind of a bit of the process there, both looking at more longer term features and more shorter term things that are usually a little bit more well defined. Those are ones that we can kind of just go after and ship.
It's very comforting to know that typical product management skills and challenges apply across the industries, including a world-class robotics company. So thank you for sharing that. That's really, really cool. Now I'm gonna move over to the machine learning side of things.
Sure.
Something that we've mentioned a few times in this conversation, and I feel it's a word or a phrase that goes around a lot. Can you first, before I even get to the question, can you explain what is machine learning?
That's a good question. So, and I'm not a machine learning research scientist, right? So I'm sure there's an official formal definition of machine learning. As the way I see machine learning, it's in some ways a subset, or we'll call it a subset of the broader term artificial intelligence, right? We'll say AI going forward, I'm sure, but I see it as sort of a subset of that. And where it resonates for me, perhaps more so than for others, is because in the robotic world, there is a hardware piece of machinery involved. So, when we talk about AI, it's very easy to, I think, by default, in some ways, think of computer systems that are looking at, large vision models and large language models, and all these different applications. In this case, there's a machine, right? And so, for me, that's the way I think about the application of, in essence, the system understanding more about its surroundings and making smarter decisions. That for me is machine learning in this case.
Amazing. Okay, so given now we understand what machine learning is, particularly within your environment, it's a huge topic that is associated with AI. And one key benefit of machine learning that I'm keen to really unpick with you is how it can help our systems make smarter decisions. And but also how it can help us make really huge impacts on some leading global issues like recycling, for example. So could you share some examples of machine learning doing just that in industry?
Yeah, absolutely. So I'll plug Stretch, and some of the machine learning that we use on the system. And most widely, the machine learning concept and Stretch applies to understanding the characteristics of boxes. So we see containers, we see a lot of different types of boxes, shapes and sizes, and there's a lot of variability involved. We
Mm.
get containers that come over from different vendors. Could be anything from like a clothing factory, or it could be like a toy factory. And sometimes the boxes will show up and um, they'll be in different condition. They'll be crushed. They'll be covered in tape. They'll have overlapping edges. We call those overlapping or interlocking facades is the term that we use there. And so it's a matter of perception in that case, where we're monitoring those different box characteristics, and we're looking at ways where we can optimize and make our system smarter by having more machine learning in this case, annotating those boxes, and looking at how we can continue improving our models, because that will then later inform the next step in how we choose to grasp that box and how we choose to move that box from the facade over to the conveyor belt. Right. So it's really a pretty crucial step for us in our flow, and how the robot sort of processes and moves through its sequence. More broadly, there's a lot of really phenomenal applications of machine learning out there. And, for me in the robotics world, one that I love to talk about, and you had alluded to it, is recycling. So there's this company called Amp Robotics, and they make a recycling system where trash comes down a conveyor belt, and there's a series of cameras involved, and so they're looking at all of the different mixed recycling, and the robot is able to pick out which pieces are eligible for recycling and which pieces need to go to the landfill. Right. And so that's a really cool application of machine learning, where the more pieces of recycling the robot can see, or the cameras or the whole system can identify and see, and then get some sort of reinforcement that yes, this was in fact a piece that we should have picked, or perhaps, oh no, we maybe picked the wrong one here. That's going to make all those models smarter, and really find ways to solve difficult problems. Where, again, if we go back to what we were talking about earlier in our discussion here, the alternative is to have a human standing there on a sideline on a stinky recycling line, when you have all this horrible trash coming down, and having to figure out what's what, and it's just not a pleasant job. And so that's really something I think is a phenomenal application for robotics and machine learning and AI. We like to say in the automation world, these dull, dirty, and dangerous jobs, the 3Ds, right? And so this is like exactly that case. It's like a really grimy, dirty job. In the warehouse, world, it's a dull job. It's not dangerous necessarily. Maybe if you do it over a long period of time in the heat, it can be dangerous. But just remember those 3Ds, the dull, dirty, dangerous. If any one of those applies to a task that a human is doing, there's that's when it's time to start thinking about how can we maybe automate that and have the human do something more meaningful.
I love that. That's a really cool way of identifying if you should be thinking of automation, because it resonates with someone so well, right? Who wants to do any of those 3Ds at work? That's absolutely wonderful. Now, with your experience, what are some of the trends that we can look out for in the future, whether it's with machine learning, AI, robotics?
Yeah, sure. I think the main trend that I want to highlight is one that I talked about earlier. I really do think this is worth repeating, and that is about the aging labor force. So, what that means for AI and robotics is that they will continue to be more ever present in the modern world. We'll see it in manufacturing, we'll see it in warehousing, but ultimately we'll see it in other places where, from a day-to-day basis, you might start stumbling into robots more frequently, right? And I think that is an exciting world. There's a lot of applications for robots in healthcare. A robot that can travel from the dining area in a hospital up to a patient's bed and deliver food, right? Like all these, there's some really interesting applications there. And I think, we'll continue seeing these, crop up. And I think there's definitely a responsibility on the designers and on the engineers and on the product managers and on the whole teams involved, thinking about this sort of end-to-end experience to make sure that the robots are approachable and that they're safe. Right, these are important things when we're working side by side with humans in the nearby vicinity. So I don't think it's going away. I think that when we look at sort of the macro trend of the workforce and sort of the population, the only place really it can go is to have more automation. Otherwise, we might see some versions of potentially some economic decline, or we might have challenges filling labor. So it's really not so much as a question of replacing labor. It will become more obvious that we will not have enough labor to do the things that we want to do in our day-to-day lives.
That's a really interesting point that we've obviously gone over again, is just the aging workforce. And also, I think there are so many other use cases where labor is needed in terms of accessibility. And I know with where the world is going at the moment, we're seeing so many forest fires and basically terrains that become inaccessible for humans. And that's basically kind of in the warehouse situation where it's hot. It may not even be an accessible place for a human to be for such long hours, let alone a desired place to be. There are just so many use cases, and I think this is a very important message for people out there who are either kind of scaremongering or also have this negative perception of robots and AI, that really with anything that's advanced in the world, there are definitely advantages to it that can be quite personal as well.
Yeah.
It's a wonderful evolution to see personally.
Yeah, absolutely. It's a lot of fun, being right there in the heart of it. What I would encourage people to think about when they are maybe listening to the podcast or thinking more broadly about robots and AI and how their lives may one day be touched. One of my coworkers, I think I'll have to just quote him directly. He said, "Come down to our QA lab, right? The robots are failing all the time, right? So we have to really be precise about the parameters and about the environment and exactly what we're telling our robots to do. They are working in a structured environment. You're inside of a container, and that allows us to do this task. But stepping outside of that container and being surrounded by humans and being in a more environment rich with anomalies and variability. This is really the human world that we're all used to living in, but it's very, very difficult for robots to work in. And so the progress here, it takes a long time to really figure out how to do that in a way that's safe, in a way that's also beneficial and valuable, in a way that solves a problem that is something that is also commercializable, right? So that's really kind of a key to all of this too. And I understand some of the skepticism that can surround the topic. But again, I encourage everybody just to trust me when I say that there is a lot of failure that goes on. And it really shows that robots are not as smart as people might think they are, right? It takes a lot of ultimately a lot of structure at the end of the day to get a robot to do something meaningful, because it really doesn't have any ability to make decisions other than what a team of developers tell it to do.
Yeah. Absolutely. It's a whole team behind a robot, which kind of says it all, right? It's human brains behind it as opposed to it thinking for itself. Thank you so much for sharing that. Now, one tradition that we started on the podcast is asking our special guest, what is the best piece of advice you've ever received, or your own advice that you'd like to give out to the world?
Sure. So I think there's a few things I definitely want to say here. The first is just to be curious. Right. I mean, that's a great starting point for anybody. If you're a product manager, if you're an engineer, if you're working on a product in any way, right? Understand, be curious. How are people using the products, right? What is the impact it's having, right? Is that are you comfortable with the impact that it's having, and then kind of go from there, right? What can you do to help make it a better product overall? And secondly, I think that product managers, like, we're really responsible for the kind of the overall well-being of the product, and I think that's like one of the simplest ways I think you can define the role of a product manager. And so there's a lot to think about there, but you have to be really mindful of when to drill down into the weeds, but also when to take a step back, and when to look at how is this applying to the business that you're serving, or the consumer that you're trying to sell to. And so, in my case, that means the product has to have documentation, and has to have, has to be serviceable, and has to, right? So these are these different touch points, sort of end to end, that are part of the equation for the overall well-being of the product. So yeah.
I absolutely love that. Andre, it's been such a pleasure having you on. Thank you so much for your answers and spending time with us today. I cannot wait to see what you do with Stretch. I'll be watching very, very closely. Thank you so much.
Yeah, and thank you, Amna. It's been a lot of fun chatting with you. And yeah, we'll see where Stretch goes, and what the future of robotics looks like.
I hope it's a very successful future and can't wait. Thank you.
Thank you.